Now see here, first one, refraction from rarer to denser medium at a convex refracting surface. Suppose you have taken convex refracting surface like this. This side is material, transparent material here. This is the line here which is called principal axis. This is your pole, and now in this case, in this line, here we take some point sized object. We take two incident rays, one like this and one is here. At this point, normal is drawn, that will be coming from the center of curvature. So this one is known as angle of incidence I. Now this ray is going from rarer to denser medium, so it will bend towards the normal, and after refraction it will be meeting at this point. This is here image. So here these two refracted rays are meeting at the point I. So real image is formed of the point sized object O. This one is a normal incidence, so it goes in a straight line without any deviation. This angle is known as angle of refraction. This we can take angle alpha, this we can take here angle beta, and this one we can take angle here gamma. We take this point of incidence is as A, and here we draw a normal, this is taken as M. So AM is normal on the principal axis from the point of incidence. Now here this medium has got refractive index mu2 and this medium has got refractive index mu1 if it is not air, otherwise here you can write 1, but here I am giving the values mu1 and mu2. So rays of light are going actually from rarer to denser medium. So now we have to get relation between refractive index of these two media, radius of curvature, object distance and image distance. So see here, according to Snell's law we can write, according to Snell's law we can write mu21 is equal to sin I upon sin R. As in assumption we have already discussed, I angle of incidence and refraction are small angles. So we can write actually I upon R, because sin I will be equal to only I and sin R will be equal to R for small angle. So we can also write mu2 upon mu1 is equal to I upon R, or we can write mu2 R is equal to mu1 I. This is here the relation here. So this we can give as a equation 1 here. So mu2 R is equal to mu1 I. Now we can solve here for this angle of incidence, values for the angle of incidence and refraction. Now we can take in this case, see here I is, in this case you are getting this I is an exterior angle. So we can write I is equal to alpha plus gamma, because this is exterior angle for the triangle AOC. Similarly we can write gamma as exterior angle for the triangle ACI. So we can write gamma is equal to R plus beta. So R is equal to gamma minus beta. So in this case the value of I and R we have got. So we can write mu2 gamma minus beta is equal to mu1 and here alpha plus gamma. This is from equation 1 I have written. Now we can, for a small angle we can also write here tan. So we can write here mu2 tan gamma minus tan beta is equal to mu1 tan alpha plus tan gamma. So this can be written here. We can write the value of alpha, beta and gamma from the different triangles. So we can write mu2 here, tan gamma can be written am upon mc. So am upon mc minus am upon mi, that is a tan beta from triangle AMI is equal to mu1, that is am upon mo plus am upon mc. So this can be written for this, and in this case now We can solve it again here. AM and AM will cancel from both the sides. So, we can write, after simplifying this, I am collecting now the term of the MC denominator and MC denominator in one side. So, we will be getting mu 2 minus mu 1 upon MC is equal to, here mu 1 upon MO plus mu 2 upon MI. So, these things we can get here. Now, we can write here MC is approximately equal to PC is equal to R, because M and P are very close to each other. Similarly, we can write MO is approximately equal to PO is equal to minus U, that is object distance negative because it is opposite to incident rays, and MI is equal to approximately PI is equal to V. Put all these values over here in this equation. So, the relation will become now mu 2 minus mu 1 upon R is equal to mu 1 upon minus U plus mu 2 upon V. So, this is the relation between refractive index, object distance, image distance and radius of curvature for convex surface when the refraction is taking place from rarer to denser medium.